Okay, I'm back in the combustion processes laboratory at UC Berkeley, and I'm going to have one of the grad students here, Andres Osorio, show you his ignition and flame spread experiment. This is an experiment that is sponsored by NASA, and they're interested in flammability of fabrics that are used on board spacecraft. The fabrics themselves are considered to be fire resistant on the ground, but in the search exploration atmospheres characterized by higher oxygen concentrations and or varying pressures, it's possible that those materials could ignite or flame would spread over their surface faster than we would expect based on tests that we see on the ground. So let me just walk you through some of the components that you've seen before that tie into Andres' experiment. Behind me is the chamber that he uses to mix gases, and he's varying oxygen concentrations. So he's using a pair of orifice plates, one to flow air, one to flow oxygen, and he's calibrated them to provide a pressure drop across the orifice plate that he can monitor and vary to provide different volume flow rates of each gas. And by mixing each gas in varying proportions, he knows the oxygen concentration that's entering his duct. Okay? And I'll walk you around to the back of this thing because I think it'll give you a better view of sort of the next step. Gases then flow out of the back side of this mixing chamber here. They flow up and into this black pipe. That black pipe goes to what's called a settling chamber right there. And the settling chamber feeds into a venturi that then feeds into the duct itself. And just as a backup for the oxygen concentration based on volume percent method that he's using, he has also placed an oxygen sensor in the top of the duct so that he can monitor oxygen concentrations as he goes. That's the duct you see there in the distance with a pair of parabolic reflector heaters that operate on a 500 or 1000 watt light bulb, essentially, halogen light bulb. Okay, we'll walk around to the other side of the duct and he can run his experiment for you. Okay, so that's Andres, and he's going to talk you through his experiment a little bit. Take it away.
So here on this side of the experiment, you're seeing the computer that we used to acquire the readings from the oxygen sensor. So here, actually, just want to take a little more time to explain this. So the white line corresponds to the instantaneous reading that comes out from the sensor, but as you can see, oscillates quite a lot. And that's not necessarily very indicative as we start changing. Therefore, like, we use an average of readings to create a more stable run that actually is more representative of what's going through the experiment. So for the experiment, basically we set our oxygen concentration we want to run at, and at that point then we allow air and the nitrogen or air and oxygen to mix so that we can actually change the oxygen concentration to whatever value we want. The current experiment we're going to do, we're going to be diluting the air to 15% oxygen concentration. The idea is to test a fabric that's normally flammable on ambient conditions, and then as we bring down the oxygen concentration, the fabric should not be able to burn bad. Adding external radiant source actually pushes or allows the fabric to become flammable, and this is the behavior that NASA is interested in studying. Is when you change the oxygen concentrations and you add an external radiant source, that actually changes the flammability to something that's not necessarily indicative of normal condition. So at this point, I'm going to start running an experiment. So the first step that we'll do is adjust the air concentration, which is down here in the back of this flow. So from previous experiments I have calibrated, I'm just going to set up the conditions, and then it takes a small settling time by the time all the gases fill the mixing chamber and flow through the venturi, so like they are all settled. And the high pitch comes just from the gases flowing through the orifice plate. So here you can see how the sensor starts picking up that there is less oxygen concentration, and then therefore it starts reducing. Because we're using an average run, the red line is always lagging behind. but as soon as we reach steady state, both lines should be really close to each other. So right now we're just waiting for a little bit. Then once we have determined that the oxygen concentration is steady at the point we want, then we will start the experiment.
Sometimes it's hard for them to hear over the air, so speak loud.
So this power supply controls the igniter wire that allows the fabric to start burning, and this controls the intensity of the lamp. So for this experiment, we're going to be using 25 kilowatts of heat flux throughout the fabric.
While Andres is looking at something, here's the heaters. There's the two heaters right here and here, and they radiate the surface of this sample right here, and that's the sample of interest. This is a fabric that was provided by NASA. The air inlet is right there by that red clamp inside this chamber. That's the igniter that you're seeing right there. And then here is our whole sample of fabric that we're interested in, and you can see where it's burned and past burns right there. Okay.
Okay, so when we start the experiment, we want to allow some time for the fabric to reach steady state temperature prior to the ignition. So for the experiments, we're going to allow for the lamp to irradiate the fabric for 2 minutes before turning the igniter wire. So at this point, we just turn on the lamps, and like I said, for my calibrations, I know that I should be at 1.29 kilowatts. The heat flux distribution for the experiments we're conducting is not constant. It's actually borrowed from the lift test method that prescribes a decaying heat flux. The reason for the decaying heat flux is that allow us to sweep over a longer range of values to determine what's a minimum heat flux for a flame spreader for ignition. So in a similar ways like critical heat flux for ignition that we are able to find from one experiment instead of conducting multiple experiments.
Andres, just very quickly, you said you do 1.2 kilowatts. How do you monitor that using your multimeters?
So from a calibration, we know basically we have a radiometer that's connected. The radiometer outputs a voltage that's corresponding to the heat flux, and prior to the experiments we have calibrated the position, so the radiometer is positioned at different locations, and this corresponds to an output. Basically the output is linear. It's like as the power increases from the lamps, so does the current and the volts running through the system. So here we're monitoring the current, but basically we monitor current and voltage that should match the power that's also coming up from the lamps. So at this point we're going to start the experiment. Actually 20 more seconds, because this power supply that creates the ignition takes 10 seconds to turn on. So right now our oxygen concentration is about 14.25 oxygen. Just fluctuates. The reason why it's fluctuating is because when the experiments conduct, usually you have to be back and forth because the pressure fluctuates, so you have to keep continually adjusting. But for the purpose of this demonstration, we're going to assume that's taken care of, and I'm more focused on explaining the behavior. So now we're going to turn on the igniter wires, and as you can see, fire is going to develop once the igniter wire. And then you can tell it's because the igniter wire is low, and then the flame starts. Because at this experiment condition, the oxygen concentration is so low, the fabric actually doesn't burn. But as you're going to see on a picture, another one we're going to make, we're going to conduct the same experiment, but this time at 21% oxygen. And the fabric is going to be able to burn really fast because we are aiding it by having an external reading source.
Okay,